Next one, we see the branches. This is another category. Branch is common ally here. Previous one in brass you have the zinc. So here we use the tin. When the tin is added to that one, it will become brass. This alloy of copper and tin are generally termed as branches. The wide range of composition of these alloys comprise from 75 to 95% of copper and 5 to 25% of tin. So these branches have high strength, better corrosion than the brasses. And it is comparatively hard and resist surface, that is wear. Wear resistance is good, and it can be shaped and rolled into wire rod sheets very easily, because starting itself we have seen they are uh, good, they have good malleability and ductility. That means under the tension, under the compression, we can change the shape and size. That is why they can be shaped easily or rolled into wires rod sheets easily. It has anti-friction or bearing properties. So branch is faster than the brass. The tensile strength of branch increased gradually when the amount of tin is increased. So when the tin is added up to 20% of maximum, its tensile strength will be increased. Okay, next one. However, the percentage of tin content, if increases beyond that amount 20%, the tensile strength decreases very rapidly. Up to some amount only we have to add that one. Bronze is most ductile when it contains about 5% of tin only. As the amount of tin increases about 5%, the ductility of that one gradually decreases and particularly disappears practically disappears when it is added around 20% of tin. Okay, so up to 5% if you add, it is good. Okay, 5 to 20% it is moderate. If it is more than 20%, so completely ductility will become disappear, so it will become very hard. Okay, whereas presence of zinc in the branch in addition to the tin increases the fluidity of molten metal, strength and ductility. Now we have different types of branches. Let us see the chemical composition types, their chemical composition properties and applications. When the branch contains phosphorus in a small amounts, then it is called as phosphorus branch. So its chemical composition: copper is from 89 to 94%, tin 6 to 10%, phosphorus 0.1 to 0.3%. So its tensile, its properties, if you observe, it has good tensile strength, ductility, elasticity, soundness of casting. That means good castability, good wearing sorry, that good wear resistance it is having. Next one is it has good resistance to the fatigue of phosphorus branch. That is resistance to the fatigue increases with increase of phosphorus in the branch. So when the amount of phosphorus increases from 0.1 to 0.3, okay, its resistance to the fatigue is increased. We should not go for beyond the 0.3%. So this material possesses good corrosion resistance, especially for seawater, so that it is much used for that is propeller blades. This phosphorus branch of proper composition can be, you can easily be casted, forged, drawn and cold rolled. So application of this phosphorus branch, if you see, bolts.
సపరేట్ చేసి పెట్టారు కదా, అది డెవలప్ చేసి సాఫ్ట్వేర్ అంటారు.
అయిపోయింది
చెప్పడానికి వచ్చాను. ఏ సబ్జెక్టు? మషిన్ టెక్నాలజీ, మెటలర్జీ. ఇప్పుడుదా ఫిఫ్త్ యూనిట్ అది సార్ మీరు చెప్పన్నారు.
ఓకే అది
కంపారిజన్ మనం పెట్టేదాన్ని ఇప్పుడు దానికి 2 months కంపేర్ చేయాలి.
Phosphorus branch is used in making of bolts, electric contact springs, bearings, bushes, gear, ship sheeting, that is valve parts, propeller blades, worm wheels, gears, nuts, nuts for the machine lead screws, pump parts, linings, and for many other purposes. It is also suitable for making springs and corrosion resistance mine cables. So you need not to worry. You write 3 to 4 applications. Those are enough. Okay, don't worry. Next one is silicon branch. So this contains 96% of copper, 3% of silicon, and 1% of either magnesium or zinc added to that one. So silicon branch has good corrosion resistance and having good higher strength. It can be easily cast, rolled, stamped, forged. These are the properties are common. So most of the 4 to 5 common properties are there. You write no problem, and it can be either cold or hot worked. Okay, it can also be welded by all usual methods. So we have different types of welding methods. You will see in the fourth and somewhere in the manufacturing technology. You will see that. Silicon branch is widely used for making of boilers, tanks, stoves, where high strength and good corrosion resistance is required. It is also used for making of screws, tubings, and pipings, etc. So now beryllium branch. Beryllium branch is a copper-based alloy contains copper 97.5%, remaining 2% is beryllium we have in this one. Beryllium branch, it possesses higher tensile strength than the other branches. It possesses excellent corrosion resistance. This is common to all. It is having high yield point and high fatigue limit, and it is a good hot and cold resistance. It can be heat treated by precipitation hardening, so that we have seen in the third unit. That is heat treatment of non-ferrous alloys. It possesses excellent formability in soft condition and high fatigue and creep resistance in hardened condition. However, it involves, that is cost of this one is more. Now application, you need not to fear of seeing these things. 2, 3 enough. Beryllium branch is particularly suitable for material for making of springs, tubes, diaphragms. So most of the common things you will see in these applications. Electrical contacts, heavy duty electrical switches, cams, bushings, and springs, heavy duty electrical switches. So this one is repeated. So these are having non-sparking characteristics. That's why it is used for making of chisels, hammers, using for such conditions where the spark might cause explosion. Okay, in metalworking process, if you use hammers, sparks may come. Such conditions, what happens? Explosion may take place. So that's why to avoid those things where they are required, those things are made by this material, that is beryllium copper alloy. It has film forming and soft lubricating properties. That's why which are used in making of bearing suitable for bearing. Since they have good wear resistance, so they are used in bearing materials in place of phosphorus branch. So they have wear resistance 5 times more than the phosphorus branch. That's why in that applications we use this beryllium brass. Next one is manganese branch. Manganese branch is usually high resistance to corrosion. This is common. It is stronger and harder than the phosphorus branch. So you need not, if you want, you can write this point. It is stronger with respect to the phosphorus branch. So magnesium branch is an alloy of copper, zinc, and little percentage of manganese. So the usual composition of this branch is copper 60%, zinc 35%, manganese 5%. Application of this manganese branches. This is used for making of bushes, flungers, feed pumps, rods, etc. So worm gears are frequently made with this branch. Next, aluminum branch. Aluminum branch consists of 85 to 85% of copper, 8 to 11% of aluminum, 3% of ferrous, that is iron, and 0.5% of tin. So they have this 8% of aluminum in that aluminum branch having good cold working properties. So when iron is added to this metal, its mechanical properties are greatly improved by refining the grain size. So grain refinement. So when the ferrous is added to that one, grain refinement takes place in this branch. It improves the ductility. So the maximum tensile strength of this alloy is 450 megapascals with when 11% of aluminum is added to that aluminum branch. So this material possesses good resistance to the corrosion, and it is somewhat difficult to cast due to oxidation problems. So applications of this one, if you say, it is generally used for making of fluid connections, fittings, gears, propellers, air pumps, bushings, tubes, slide and valves, cams, rollers, which are commonly made with aluminum branch. So final one is bell material, bell metal, this having 66.7% of copper, 33.3% of tin. So this is very strong. It possesses good resistance to the corrosion in water and atmosphere. So which is used in making of bells. In schools you might have seen the bells which are made with this metal. Okay. So especially these non-ferrous alloys, there is no way that here you have to by heart and remember all the things. Thank you. రామకృష్ణ ఇది ఎలా ఆపేది దీంట్లో ఇక్కడ ఏడ ఉన్నాం క్యాంప్టేషన్లోనే ఎక్కడో ఇది గంట 5 నిమిషాలు చెప్పామా